All right, this is it. Last part. Independent events. Independent events are two events are independent when one occurrence of one has no effect on the occurrence of the other. Okay, so one example is if you had two coins and you flipped one, comes up heads, no matter what comes up on that first coin, it's not going to make any difference to what happens on the second coin. You flip the second coin, comes up heads. Whatever happened on the first one had zero to do with the second one. So that's what we call independent events. And a lot of times we want to, it's kind of like permutation a little bit when we do the math about it. Okay, so let's take a look at some problems here. A random number of on a computer selects three integers from 1 to 20. What is the probability that all three numbers are less than or equal to 5? Okay, so we've got to figure out what our event is. First of all, our event is where the numbers are less than or equal to 5. So let's start figuring out what our sample space is. It's from 1 to 20, so we've got 20 to choose from total, or 20 possible outcomes. And the only outcomes we're looking for is where it's less than or equal to 5 is going to be 5 of them, since it's 1, 2, 3, 4, 5. So, and it's 5 of them. Okay. So the probability of A is 5 out of 20, which equals 1/4. Okay, so here's the thing. We are going to select three integers. Okay. So they're all independent. They have nothing to do with each other. So let's say we pick the first card, or a random number. Pick the first number, okay? The probability that the first number is less than or equal to 5 is 1/4. Okay, so we got a 1/4 chance that we're going to get that number. The second one, the first one has nothing to do with it. It's going to be 1/4 again. The third is 1/4. Okay, we'll multiply it all together. We get a 1 out of 64 chance that all three numbers that it selects is going to be less than or equal to 5. Okay. All right, in 2012, approximately 27% of the population of the United States got their news from mobile devices. In a survey, researchers selected 10 people at random from the population. What is the population that all 10 got their mobile devices? All 10 got their news from a mobile device. All right, so we got 10 people chose at random. Okay, so the A, our event, is the population I see getting their news from mobile devices. So news from mobile device. Okay. so we got 10 people. Actually, let's draw stick figures since they're people. Four, 5, 6, 7, 8, 9, 10. So 10 people. Okay. It says here approximately 20% of the population got their news from a mobile device. So in each one that we approach, we've got a 27% chance that that person is using his or her mobile device to get the news. Okay, so how we figure out this probability? Okay, that's going to be 20%. See how we have like the 1/4 times 1/4? So that's 0.27 to the 10th power. Same with up here, that's just 1/4 to the 3rd power. Down there, 0.27 to the 10th power, which is going to give us 0.013, so about a 1% chance that all 10 of them got their news from a mobile device. All right, winding it up. Complement of it. Okay, the complement of event, I just kind of like to call it the opposite of what's going on. You know, I got a 90% chance of winning. My complement is I have a 10% chance of losing. Okay, so by definition, the complement event is the collection, or we'll put A here, is the collection of all outcomes in the sample space that are not in A. Okay, so when we use this complement, okay, the complement of event A is denoted by A, we call that prime. Okay. Mathematically, it's going to equal 1 minus the probability of A. Okay. So either we find the probability A, we can find this complement, and therefore, all right, let's take a look at this. A manufacturer determined that a machine averages one faulty unit for every 1,000 it produces. What is the probability that an order of 200 units will have one or more faulty units? So we're looking for an event where it's one or more. Okay. What we can do is, instead of A prime would be that. If we have A, that means that the probability that it is not faulty. So let's do a probability of A. So it says it produces 1,000. Okay, one of them is faulty. Okay, so 999 of them are okay. And we have 1,000 to choose from. Okay, so that's going to we have to have a probability of 200 of them. So we'll just do that and put it to the 200. Okay, because we don't want to do 999 over 1,000 200 times. Okay, and that's going to give us 0.819, so about 82% probability that you will actually have them actually being good, not faulty. All right, so we want to find where it is one or more. Okay, we'll take 1 minus this 82%. Okay, so that's leaving us with 18%. Okay, so this 18% is telling us that there is an 18% chance or probability the probability that an order of 200 units will have one or more faulty units is 18%. Okay, and that's it. All right, hope to see you guys soon. Bye bye.